This is an example of a type of three-phase load bank, in this case a resistive load bank, used to test three-phase generators. There are a total of 6 terminals, which is the case in any general three-phase port, and to successfully connect that to a three-phase source, you have to reduce the 6 terminals to 4, in this case by using a Y connection. The black terminals, or black jumper wires, go from one side of A, B, and C, which creates a common or neutral point. That neutral point goes to the source, and then we have 3 remaining for the A, B, and C connections to the source. In this particular resistive load bank, the separate A, B, and C resistors of the Y connection can be changed independently. Our switches switch in and out individual resistors inside the unit, and the switches are labeled with watt values, assuming that 120 volts AC is applied. We have switches from 400 watts to 300, 200, 100 watts to provide a wide range of load here. The maximum load at 120 volts input, 3-phase, will be 4.2 kilowatts. The types of resistors used in this resistive load bank are wire-wound resistors wound on a ceramic cylinder. The ceramic cylinder serves 2 purposes. The wire is somewhat heavy gauge to handle the amount of current flowing through the resistor, and it provides very good heat dissipation. We have many banks of resistors which are wired to the switches. The top 3 resistors here show a good example of a parallel resistor connection. Notice the 3 cylinders, those are 3 separate wire-wound resistors, and the jumper wires across all 3. Same thing on the reverse side, which provides 1 net resistance using 3 resistors connected in parallel. This is, of course, done to give you a net resistance that is 1/3 the value of 1 individual resistance. The lower resistance gives you more current and more power dissipation.